So the first thing I want to do is I want to take a look at example 2 here. I think I should rewrite this a little bit, but before I rewrite this, does anyone know what the outside function is going to be in this problem? Yes, example 1 used functional notation. That is correct. Right, Aisha. Anyone know what the outside function is for example 2? Any thoughts? Correct, Steph. So what we're going to do is we're going to rewrite this like this. This guy is going to be cos, or let me write it in black. This function is really cosine of x quantity cubed like this. Okay. So when I look at this guy, basically what I'm thinking is I'm thinking the outside is x cubed and the inside is cosine of x. So let's do this. So when I calculate h prime of x, I take the derivative of the outside. What's the derivative of the outside? It's going to be 3 times something squared. Any questions about that? Now you got to keep the inside. The inside is cosine of x. And you got to multiply by the derivative of the inside. So the derivative of the inside like this. I'm going to do it in 2 steps. Any questions about that line? I just apply the chain rule. Take the derivative of the outside, 3 something squared, keep the inside, cosine x, multiply by the derivative of the inside, which is cosine x. Now this is going to be 3. A lot of times when we say cosine squared, we write it like this, cosine squared like that, x. And then the derivative of cosine is negative sine of x. This answer is not wrong, but usually we move the negative to the front. So this is going to be negative 3 cosine squared x times sine of x. And then that's going to be our final answer. Is there any questions about this example? Oops, sorry. Is there any questions about this example 2? All right. I did have one comment in the chat box. There was a student that said the outside function is cos cubed like this. And this doesn't really make sense. You always have like, you can't separate the cos cubed and the x. Like cos cubed doesn't mean anything. Only cosine of x means something. Writing this cosine without an x doesn't mean anything because this cosine's a function. Okay, so this would not be the way to think about it. All right, let's take a look at another example here. We want to find the equation of the tangent line to this graph right here. So, and we're at the point x equal to 2. So we know that there's 2 things we need for the equation of a line, a tangent line, right? The first thing we need is we need a point. And how we find the point is we're going to get 2 and h of 2, right? And we know that that is going to be equal to two comma, when I plug a 2 in, I'm going to get 1 over 1 squared, which is just 1. So it's 2 over 1. But the second thing I need is I need a slope. And to find the slope, I take the derivative. So we want h prime evaluated at 2. That will give me the slope of the tangent line at x equal to 2. So clearly we're gonna need to take a derivative here. And does anyone know what the first thing I should do is even before I take the derivative? We probably want to rewrite the way h looks. I always like to write things in exponential form. So I'm going to write it as 3x minus 5 to the negative 2. Does that make sense? Okay. And then what I'm going to do now is I need to identify what the outside function and what the inside function is. So what do you guys think the outside function is? What do you think what's the outside first? It's going to be x to the negative 2, right, Desmond? X to the negative 2. I can understand if you're thinking something to the negative 2. That's a better way to think about it, almost like something to the negative 2 power. And then the inside function is going to be 3x minus 5, right? So when we go to calculate the derivative of the outside function, h prime of x, we should take the derivative of the outside. So there the outside is going to be, you bring down the negative 2, you keep the inside, and then we're going to subtract 1 from the exponent. So this would be minus 3. So that's the derivative of the outside. Does that make sense? Now I want to keep the inside. So I'm going to write in the 3x minus, maybe I'll do it in, should I do it in a different color? Is that too confusing? I'll just keep it, I guess. 3x minus 5 times the derivative of the inside. Okay. But what's the derivative of this inside function here? Oops. That's just 3, right? It's just a line. A line has the slope equal to its slope. I guess that's obvious. So when I simplify this, I'm going to get, I guess I just rewrite it, negative 2, 3x minus 5 to the negative 3 power times 3. Okay. Is there any questions about this so far?
Professor, I have a question.
What's your question?
So the negative 2 and the negative 3 is the outside function, not the inside function, correct?
Correct.
Okay, thank you.
You're welcome. I will always, at the beginning, write this extra, not this extra line, but this part where I multiply by the derivative of the inside function. So the inside function, you'll see it there, and you should see it here as well. It's only in the next step I calculate the derivative. Okay. Great. So now what I want to do is I want to plug in the, I want the slope at the point x equal to 2. So I'm going to plug in the 2. So this is going to give me negative 2 times 1 to the negative 3 times 3. And that's just equal to negative 6. So I'm in a good position now to write my equation of the tangent line. So that's going to be y minus 1 is equal to negative 6x minus 2. And that gives me y minus 1 is equal to negative 6x plus 12. And this gives me y is equal to negative 6x plus 13. Is there any questions about this one, my friends?
Yeah, for 1 to the negative 3 power, is that's 1 over 1 to the 3rd power, right?
1 over 1 to the 3rd power, correct? Which is 1, right?
Oh yeah.
Yeah, cool. Okay.